Okay, so let's continue. So this one is your MATLAB R2020. As I mentioned previously, that you need to install into your computer. So our university, UTEM, already purchased some academic license of MATLAB for us to use for academic purpose. So all of you can follow the step given in the ULEARN in order for you to install MATLAB R2020 in your laptop or desktop. Okay, so from here we want to create a model of our Kottaka model in Simulink MATLAB. So from here you click new, okay, we go to Simulink model. Okay, so from this open new window browser, okay, you can choose a blank model. So under here blank model, okay, we create a model. Okay, so I maximize the Simulink web browser. So here you can see the interface, okay, the window here. So this one is a library, so you can click, you can see the Simulink library browser. So most of the time we use commonly use block. Okay, I click and then you can see here. Most of the time we use this one. Okay, mat operation. Here, product. Okay, later on I will teach you on how to create a model step by step. Okay, source. Okay. So this one is a browser. Okay, this one is the debug. Modeling. Okay, and then the format. Okay, so from a library browser, from our equation, we want to create equation 1 first. So from acceleration, we want to go to velocity, and then velocity go to displacement. What we need to do is integration, meaning that if I integrate the acceleration, I will get the velocity, and from a velocity I integrate, I will get the displacement. So the base model we do is integration. So from a Simulink commonly used block, okay, I choose an integrator. Okay, you can click and then drag the integrator into your project. So how to make this one bigger? Okay, you can scroll your mouse, scroll up your mouse. If you want to zoom out, you can scroll down. Okay, and then if you want to move up like this or move down, you just pull uh, your scroll mouse and then you up and down your mouse. Okay, so I want to add some notes here, so I click annotation, this one here. So I define here as a displacement, acceleration. So I mention as a ZS sprung mass acceleration for sprung mass double dot. So this one notation as a acceleration. So acceleration for sprung mass, I integrate, I will get velocity sprung mass. Okay, so I want to integrate another time, so I copy, I paste. Okay, you can click copy, Control C, and then you paste, Control V. Okay, so from here, from velocity, I integrate, I will get a displacement. So here I mention as a sprung mass displacement for sprung mass. Okay, so to connect between this integrator or this block diagram, so you can drag the arrow here. Okay, this one for sprung mass, and then we need to do for unsprung mass. So you can copy all this one, copy, and then paste here and rename as a unsprung mass velocity and acceleration. Okay, unsprung mass velocity, and then this one is unsprung mass displacement. Right, we go back into our equation. So for the first one, I want to do this one. Okay, Zs minus Zu. Displacement sprung mass minus displacement unsprung mass times with K. K here is a spring constant. Okay. So go to our MATLAB. So go to the library browser. So for the K constant or spring constant, I use K. Okay. So the operation is we need to do Zs minus Zu, and then after that we times by K. So here is a K, Ks, spring constant. So the operation Zs minus Zu, okay, we go to the max operation, okay, minus, okay, try to subtract this one, okay, subtract, okay, inside the equation Zs minus Zu, okay, into our simulink, Zs minus Zu. Okay, I try to move this little bit. Okay, you can move using your arrow in your keypad, in your keyboard. And then Zs already minus with Zu, and then after that times with Ks. So I need to time with Ks. So the value for Ks we can refer into our lab sheet. So value for Ks is 36,500 Newton meter. Okay. So how to key in? You just double click here. 36,500 Newton meter. So we apply. Okay. So you might want to make it more bigger, okay, in order for you to see the value inside the block diagram. Okay. So this one finish. So next one we want to do for this process, velocity and velocity sprung mass minus velocity unsprung mass, and then after that times with damper coefficient. So from here, okay, same again. This one we copy. Okay, Zs velocity for sprung mass. I put here minus with velocity unsprung mass. Okay. And then times with Cs. So this one copy. So I put a notation as a Cs, damping coefficient. So I link this one, and then the value, don't forget to change the value for damping coefficient, so you can refer it to your lab sheet. 1100, okay, 1100, okay. So next one is this one already done. So we want to link back into this one. So in order to do that, okay, actually we need to move this become division. We need to divide. Okay, and so what need to do? This one. Okay, the process is this one is plus plus. Plus plus. So this our simulate, we need to plus these two process. Okay, okay. So we need to plus plus. Okay. So you see here is a plus minus, is it? But we can change this, don't worry. So double click here into your block diagram, and then you change to plus plus. Just change it plus plus. Okay, and then we need to divide with ms sprung mass here. So divide with sprung mass. So from here I copy. This one means you times, okay? Multiply. But in order for us to make it divide, so the mass, this one is I put annotation sprung mass. Okay, the value for sprung mass is 180 kg. So in order for me to divide for sprung mass, I change to 1 over 180 kilogram. Okay. So I tag the value here. So this one I need to look back into our ZS. You move down, and then you tap to here. Okay, just make it straight. So this one you done for equation number 1.